Hi again. And this session also will continue our discussion on survival models. Now we'll take in new notation. So we are building our notation. So slowly, I think we will get comfortable with the new actuarial notations. As I mentioned, most of the things we know already, but it's just like we're using different notation. So if you remember what we did last time is we looked at a life that start at age 0 for events to happen in the future. So we're looking at age 0, right? So we looked at maybe death will happen somewhere. So we look at the entire life. We use x and f of x to look at this one. What we are looking at now is, instead of looking for the entire life, which is more realistic in most cases, that in insurance industry, that the life already reached age small x here. So we know that the life reached the age of 20, 30, so it's not at time 0. So what we wanted to do is to move to, it's becoming like conditional kind of a probability. So the event of death, it might happen, at sometimes in the future here. The big X happen here, right? And this is a small x. So we used to look at the entire life. So now we're going to look at the remaining life, and we're going to use the notation tx. So tx is the random variable for the remaining lifetime. So if we define t of x is the remaining lifetime, or remaining time, let's say remaining time for what? Until death. But the difference between t of x and the usual x is now for a person, and this is the difference here, is that the person now reached the age of x. For a person reached or has already reached age x, right? So it's kind of conditional. So already that it tells us that this is conditional. There is conditionality here, that we know that the life reach like it's a conditional life. It already, we have more information that the life is, the age is not 0 now, it's x. So in actuarial notation, just also it's a good habit that because my handwriting is really bad, so I would usually show you how it looks, the actuarial notation, and then later on when I write it, you know what it is. But it's also, you review the textbook as well. So what we are looking at here is, for the new notation, we'll start, not this one, this is the one we introduced it. We need not at time 0, but rather at the time x. So let's use this one to try to understand what is this one. So let's look at this one. Now it's different here. It's not the same one we looked at. So what I want you to see first, here we have x is the age, the new age, the given information. T is, or if I draw a line to represent this new notation, so this is time 0, this is time x, and this is time x plus t. Right? So this one, it tells us p of x is survival, right? It's a survival function. So px is that the life, we are here, the life already reached age x, right? This is the age x. And what's the probability for the remaining lifetime? This is the remaining lifetime to survive to age x plus t, right? So so death will not happen here. No, death will happen after this. So the survive for the life to survive to life x plus t, right? It makes sense, right? So this is really the new notation, but it's actually the same. Like if you write tpx in our old language, tpx in our old language, this is a conditionality, right? It's, now we can use probability of x. What is x? Usually is time of failure or time at death, that survive to x plus t. Death happens at x plus t, right? Given that the death is greater than x, the small x, right? Because given that they survive they reach already this is usually we use this one as a small x, right? So this is a small x. So what's given information that the big X, the death time at failure, it's after the age x, the small x. So the death happens after. This is given, right? This is given that the life already survived x. So TPX, it tells us what is the probability of death, the big X, occurs after x plus t, because this is survival, right? It's survival, right? You can think about it. Yeah, I mean, you can think about it if we introduce a new survival function, but not s of x, it's s of t. We write t of t to differentiate it between the original survival function x of x. This one we start from time 0. This one we start from here, time x, right? It's a little bit, now we need to get used to the new notation. We're adding lots of notation, same logic, but we need to use the actuarial notation. This TPX is this one. Now let's try to manipulate it a little bit. You remember, given, we can change it into and, so it becomes probability of x greater than smaller x and t, right? And this is, we maybe use different color, and probability of x greater than x divided, remember what's after the condition goes to the denominator, probability of x greater than x, right? This is x, sorry, right? It makes sense, right? It makes sense, right? So what we can recognize that this is redundant here, x greater than x plus t and x greater than x. So the common between them is we can reduce it to probability of x greater than x plus t, right? It's redundant. We divided probability of x greater than x. And this is neat. This is very neat. This is very neat because this one you can write it TPX. Remember what we are doing, TPX, which we also introduce in U, which is a survival function, right? Which is ST of t. Survival function, not of x, but ST of t. We can relate it to our old S of x. This one, if you probability of x greater than x plus t, this is a survival function of x. This will be our old notation is x plus t, sorry, small x, divided by survival of x, right? This is something we need to keep it in our mind. We need to remember it, right? Very important. It's everything we will take about remaining lifetime, the new t of x. Usually we divide by something which is usually survive to x. We divide by survive to x because this is a conditionality. So it's the same old lesson we took when we were evaluating at age 0. The only thing here we divide by s of x because it's conditional. Why it's conditional? Because t of x, the remaining lifetime, is conditional here. And this we have to factor it in the denominator. It's a typical conditional probability, right? So everything we do, it's the same, but we divide by t of x, right? And this is straightforward. There is nothing nothing difficult about it. I mean, you can also, yeah, I mean, that's enough. Yeah, I mean, you can, if you want, this one can be also written if in also actuarial notation. This is p of 0, if you remember, x plus t divided by p0 and x here, right? Yeah, same notation in the past, right? Let's take example to help us to illustrate what we mean. And usually, just to simplify it, we start with, like our friend, the uniform distribution. So x, and when we say x, it's the whole life is uniform. It's, the life at, the random variable. It's life until failure or age at failure. So it's age at failure, random variable, is uniformly distributed between 0 and 100. This is a typical, like we've done many questions. The question is to find TP40, right? TP40. We can immediately define it because we know TPX. X usually, as I said, this is usually the age, the new age that the person survived to. Because we know what it is, we know the formula here, but if we forget, we divide by, make, because it's conditional, that survive to age 40 is the condition. So, but we know the formula, so we move from TP40, we moved our old S of X, but our X now is 40, survive to 40, and now TP40 is the new variable is T now, it's not X. X has become like a constant. So it becomes now S T plus 40, right? I applied the definition here, right? But we need to recall what is, for uniform distribution, what is S of X? S of X is equal to, for uniform distribution, by now we should remember it, is 100 minus X divided by 100. And this 100 is our omega in general. Right? This is, I told you to memorize it, and by now you guys, you should very comfortable with it. So what is, oh yeah, what is then our TP S plus T, T plus 40? Now T plus 40 is our X, we plug it in here. So it becomes 100 minus T plus 40 divided by 100, and everything here, this is the first one. Now we need to find S40. S40 is very easy, it's 100 minus 40 divided by 100. We do some cancellation here, and we take the 100, we take from it 40, so this one will give us, let me put it here, it will give us now T 60 minus T divided by 60, and this is TP40. We can generalize it if you want. You can generalize it. TPX will become 60, or not, no, comes omega minus X minus T. Remember, it's 100 minus, we did 40, it becomes 60, divided by omega minus X. Right? But in general, and this is something I mentioned before, but in general here, what is the story here is, what we want in general, the story here, if X is age at failure, if X is random variable that is uniform on 0 and omega, then T of X, and you know what's T of X, is the remaining lifetime until death for a person who reached the age X, the remaining lifetime until death of a person who aged X. So the remaining lifetime of a person age X is also uniform, but now not on 0 to omega, but on 0 and omega minus X, right? Right? So omega minus X. In our case here, we have X reach the age of 40, so omega minus 40 becomes 60, right? And this is, then once you do that, then T of X, we know everything about T of X, right? We can calculate f of X. Well, I mean, we'll come back to it, but just like to keep this in our mind. But TPX then becomes easy, is omega minus X minus T omega minus X. You need to remember, my friend, here, T is now, this is the this is like the old X. Omega minus X, this is constant. So X for this case is no longer, our variable, it's constant. These are constant. because these are constant now. Right? Does that make sense? Right? It should be straightforward. It's not nothing, you know, like difficult to worry about. But since I mentioned f of x, let's take to another topic. So now we know what is t of, oh sorry, let's use the same color. We know what is t of x, right? Everyone knows what is t of x now. T of x is the remaining lifetime, right? We need to keep this. It's the remaining lifetime random variable for a person who reached the age x. So this is the remaining lifetime, or like remaining lifetime until death for a person who reached the age x. Always we need to remember it's person 0 reached the age small x, and death happens in the future. So the remaining, so like the big X happens somewhere in the future. So the remaining lifetime, this is t of x until death, right? This is very important for us to keep it in mind. But what is CDF, cumulative distribution function of t of x? We need to look at, and what is also, we need to look at CDF, TQ, then we look at the density function, and we look at the force of mortality function. Let's take one by one. Remember S of x, S of t, I mean, of t. S of t, what we use TPX, the new notation. We said is somebody age 0 reach the age small x, given that they survive to age x, and somehow like then we have another period, it's x small x plus t, new age. So let's say 40, and the t is 10, so 40 plus 10 is 50, and this they survive here, right? Survive to here, so life continues. Now we need like ft of t. Now it's not f of x, ft of x. Just I put t here to remind us we're talking about t of x, not f of x, right? The new notation here, let me also include it as a picture, so don't confuse you with my handwriting. At least you see it first time, and then you know what I'm talking about. We call it TQX, right? It's not TPX, TQX, which is now which is actually 1 minus TPX, right? Or let me write it in another line, which is equal 1 minus TPX, right? This is 2QX, this TQX is now age0, age x plus t, this age x. Now this is somebody survived to age x, maybe age 40, and the death happens between x and xt plus t. I shaded it, so this is where death happens, somewhere here, right? So TQX, the way we read it, Q, we know Q, it represents mortality. X is the age that they already reached, they survived to, and T when death happens. TPX is opposite. Is X, yes, the days they survive to, and then they also survive to another additional T years, maybe 10 years, 15 years. But here QX is death, so reach age X, and they die within the next T years, right? And this should be straightforward for us, nothing difficult here. So what we can say, TQX is, actually you can think about it as probability of the remaining lifetime until death is less than t, right? Remember, t of x is the remaining lifetime, right? Remaining lifetime until death for a person who reached the age x. So t of x, because we know the person reached the age of x, so it's death be less than t. And we, as I mentioned, we denote it, it's f t of t. It's not fx of x. But what's the beauty about it, tqx is 1 minus tpx, right? And we know what's tpx, we already talked about it. Remember, it has to be somewhere, we need to remember, like divided by s of x, right? Because it's conditional on surviving to s of x. So this will be s x plus t. small x, I mean, right? Because tpx, we know, if you following me, tpx, we discussed it, it's already here, right? Here, oh, where it is, yeah, it's already, we define it here, sx plus t, sx. So if we take it from 1 minus it, then we get this relationship, right? And this is very important to remember, but this is s of x, right? We're talking about s of x, not s of t, right? And this is very important. Let's talk about, for the same example. Now the life, the x age at death for like this is the x, not the t, is uniform, and x is the whole life from 0 to whatever the death happened. So it's uniform on the typical story 0, 100. And the question here is let's define t of 40 is remaining lifetime until death. Again, I wanted to keep defining it to settle in your mind, you know, like this concept, until death for a person already reached 40. So this is what we wanted. And then the question is find TQ40, right? TQ40, there are several ways to do it, you know, like, but the easiest way is to remember that it's 1 minus TP40, right? And this is 1 minus TP40, if you remember the s of x here, and this is of x, and s of x plus t, right? But for uniform distribution, recall that s of x for uniform, this is x, of uniform distribution, s of x is, remember what it is? It's omega minus x divided by omega. And our omega here is 100. So 100 minus x divided by 100. So now we wanted, this one is now the x, we remove it, we replace it with 40, right? Because the question here is 40 ish, right? So if we do that now, let's take s1 minus s40 plus t, we plug it in 100, it will be 60 minus t divided by 100. Everything here is divided by, now you plug in the 40 into this one, 100 minus 40 is 60 divided by 100. These guys, they cross out. So what you have is 1 minus 60 minus t divided by 60. You can also 1 minus 1 t divided by 60, right? So this one, TQ40 for uniform, TQ40 for uniform is t over 60, right? Simple, T40. And this is similar also like to the same relationship that what we discussed in the past, that if x is uniform, remaining lifetime for a life, or for a life reached x, and this is tx, is also uniform. And if x is uniform or between 0 and omega, this one is uniform, but instead of 0 and omega, it will be between 0 and omega minus x, right? So then for t of x, tpx will be simple, right? We already did s of x plus t for uniform, and this is for uniform, right? Remember? It will be now it's this is like s of x, so it will be omega minus x minus t divided by omega minus x. We already talked about it. tqx, which is 1 minus tpx, but it will be t divided by omega minus x. So we can quickly solve questions. But what f of t? For uniform, it will be simple, 1 over omega minus x, right? And how we got this one, let's work on it. How we get it? Because we know that remaining lifetime is uniform, so it's the same thing, that the density function will become also 1 over, instead of omega minus x. So if the whole life is 0 to 100 and the remaining life is 60, then the density function will be 1 over 60, not 1 over 100. But in general, ft of t, this density function of t of x, density function of t of x, ft of t, and this we can divide, always we divide by s of x, right? Because this and this is of x, we need to divide by s of x, because the life, we given more information that the life reached the age of x, so we need to divide by it, and this is f of x, x plus t, right? It's simple, right? It's simple. Always we need to divide by the information given to us, right? But you can, in actuarial notation also, we can write this one also, like play with it in actuarial notation. Remember when we took m of u x, we said it's f of x over s of x. If you cross multiply, if you remember, we said f of x is equal survivor function multiplied by mu of x. Now, same logic here. If you do f of t, not f of x, this remaining lifetime, this will become now, instead of s of x, become s of t multiplied by mu x plus t. This is the new notation here. So f of t, this s of t, we know it, it's sx plus t of x divided by s of x multiplied by mu x plus t. Right? Those all of them we need to remember them. They are one like the same concept but in different notation. And the other notation for f of t, the density function of the future lifetime, and this one, remember, it's tpx mu x plus t. Right? We need to know all of them, all the notation. This one usually we use it very often, right? And this is something we need to keep it in our mind, not to forget about it, right? So the density function is this one. Let's take the example again, the one I already told you the answer, because for normal distribution, I told you the f of t will be 1 over omega minus x for uniform. But let's derive it now. I give you the shortcut because we know the remaining lifetime is uniform. So that's why I derive it quickly. But let's say wanted to derive it ourselves. So now x, and what is x again? Life, like the random variable or age at death of random variable, right? Or age at failure random variable. So it's uniform. Let's take the example again, 0, 100. Let's take simple examples so we understand the concept. Later we'll take harder examples. So now we have x is uniform between 0 and 100, right? And the question is define T40. And what is T40? I already wrote it for you. Is that the T40 is the remaining lifetime until death for a person who already reached the age 40. So what's given to us information is that they reach the level of age equal to 40, right? So what we wanted to do now is to find, so it's find ft, oh sorry, of t. This is not f of x. F of x is easy. If f of x is 1 over 100, it's simple. But this is f of t, the remaining lifetime. So this, the individual is 0, reach the age 40, 100. We are looking at this t of x. Now we need to find f of t for t of x, right? For the future lifetime. So there are two methods. Actually more than two, but we'll, because I gave you two. So f of t, we need to find f of t for the uniform distribution. So the first method is f of t, remember it's the definition itself. I already gave you the definition here. Any one of those, but I think we can take the first one. Let's take this one, right? So we take f of x divided by s of x, right? Oh, sorry. Right? We take f of x divided by s of x, right? F of x plus t, right? So let's do that. And this one will be f, now using the original one, x plus t. And instead of x, this is 40, because the age is 40, divided by f of 40. Right. And remember that, recall f of x, the density function for the life at 0 is 1 over omega, which is 100, right? For our case. Oh, sorry, here divided by s of x, s of 40, right? And why s of 40 again? Because we are given information that the individual already survived age 40, already reached the age 40, right? So what we wanted to do now is take 1 over 100 divided by s40. What, remember what s40 is? 100. Oh, sorry. Yeah, 100 minus 40 divided by 100. Right? We cross this with this. What is left is 1. Let me use the same color. What is left is 1 over 60. So f of t is 1 over 60. And this is actually one, this is like in another, in more general form is 1 over omega minus x. Right, in the general form. For uniform distribution, the remaining lifetime is also uniformly distributed. So the remaining lifetime is uniformly distributed, but instead of 0 to omega, it becomes between 0 and omega minus x. Right? This is one method. The second method, what we're gonna use is this relationship: tpx mu x plus t. Now f of t is tpx. Now x is 40. Mu x plus t, which is 40 plus t. And recall P40, we already calculate s x plus, sorry, 40 plus t divided by s40. And we already computed it because this is uniformly distributed. It will be 60 minus t divided by 60. I already computed in 2 minutes back, but you can always verify it, right? So now, what is mu 40 plus t? Mu 40 plus t, this is the force of mortality for uniform, or let's for uniform. Recall for uniformly distributed life, mu x is equal to 1 omega minus x, right? So now because we're looking for 40 plus t, we replace it in, instead of x, it becomes 1 minus omega is our 100 minus x is 40 minus t. Or let's put it this way, right? And this I replaced sorry, just to know what I'm doing here is I replaced this x with this, right? So now if you do this, then mu 40 plus t is become 1 over 100 minus 40 is 60 minus t, right? So now we go back to our friend, we got the two terms, this one and this one, right? We got them. So we go back to this term, which is now TP40, 60 minus t divided by 60. Now we multiply it again by 160 minus t. We cross these guys together. What is left is 1 over 60, right? And this is exactly like this one, right? Which is exactly 1 over omega minus x, right? And this is a very important set of notation. There are another thing, you know, related to this discussion. We looked at tpx, and then we looked at tqp, tqx also. What if you see something like px without anything here, and same one but without any t, nothing here? If it happens you see nothing left, nothing on the left, then this actually it's 1px and this 1qx. So if 1 is not written on the left, it means it's 1 in standard actuarial notation, just to remember this. So this 0x and this x plus 1. So this means surviving to surviving x plus 1. This one 0x x plus 1. For qx, death happens here. So whenever you see qx without the 1, it means 1qx. It's like this. So qx, it's similar to 1qx, right? It's the same notation. So yeah, I think with this I think maybe just like a quick reminder of what we did. S of t is t, just let's say summary quickly, because I know lots of new notation can be confusing. It's really not hard, but you need to repeat until they settle in your mind. So S of t is, we use tpx, right? And then we looked at also and this is what we said, 0x x plus t, and you survive here. Then we look at tqx, is death happens between x and x plus t, right? And this is the ft of t. Then we looked at density function of t, and we define it in multiple ways, but the tpx mu x plus t, right? We looked at it this way, right? And for also like a summary for uniform, or let's say x, if x is uniform, and we know but what is x on 0 and omega, x is time until death of random variable, then t of x is also uniform between now 0 and omega minus x. So once you do that, then tpx, tqx, or f of x, cumulative function, survival function, density function, mutx, the force of mortality, all of them become easy to compute. They become so easy to compute. I think with lots of notation I gave you today, not really that hard, but what is hard about them is like to get used to them. So I want you to keep repeating this until it settles in your mind. Later on we'll add other terminology.